number of existing cases at a particular time divided by the population at risk. So prevalence, we are going to have two types of prevalence. There is point prevalence, okay, which look at the number of cases at one point in time. That is point prevalence. Then there is also period prevalence, okay, which is the number of cases um, during a specified period, okay, during a specified period of time. Yeah. So we are for period prevalence is given as with this formula. So there should be a specified period of time, maybe from this month to this month. We're looking at the number of cases, maybe from June to October. What is the number of cases of disease at during that given time? Okay, during that interval. Then point prevalence is just at one point in time. So if today I want to determine maybe the prevalence of malaria, I'll just count all the cases of malaria today and I'll calculate the point prevalence. But if I want to look at the period prevalence of malaria, I have to look at I have to choose time interval. From what time to what time am I looking at this prevalence? Maybe I want to know the prevalence for malaria from um, January 2025 to December 2025. What was the prevalence of malaria? So that is the difference between um, time point prevalence and the period prevalence. Okay, so we are given this example here to look at the prevalence. So when we look at the incidence, first we need to find the incidence of this disease, this condition between January 1st and December 31st December. So what is the incidence here? So anyone who can help us to determine the incidence or to tell us the incidence. How many were new cases here? Mr. Edward, how many were new cases between 1st January to 31st December? Anyone?
So let me try.
Yes.
I think the new cases were case 3, case 4, case 5, and case 8.
Okay, yeah. So the new cases that happened, looking at those diseases that started after um, January, after 1st January. So we are looking at the new cases. So we have this one here, have this one, case 4, have case 5, this, yeah, and the case 8. So the new cases of this disease was 4 cases. It was 4 cases. We can divide by the total to find the incidence rate. Okay, so this is the new cases. Then when you look at point prevalence in January, what was the point prevalence in January? So you want to look at how many cases we had in January. Okay, so the point prevalence in January is going to we are going to look at this one. We had this case here which was there in January. We have this case as well, and this case here. So these are the point prevalence in January. Okay, then what about the point prevalence in December? What would be the point prevalence in December? You know,
I think 7.
where's 7? Point prevalence in December. This 7 here,
I meant 7 cases.
or 7 cases. Okay, let's identify them. Let us identify them. Which one are these cases? We have
1,
case 1,
case 2. There are 4
case 2,
cases.
case 2, this one as well,
Case 5.
and
8.
case 8. Okay, yeah, so we have how many cases?
There are 4.
We have 4 cases in December, as of December 31st. So that is the point prevalence there. What about the period prevalence between January 1st January and December? What is the period prevalence? 1st January and December. So when we are looking at 1st January, we're looking at all the cases that are there between 1st January and December. All the
About
cases.
7 cases.
We have, let's
Choose 1.
identify them. 1,
Case 1. Case 2.
case 2,
Case 3.
case 3,
Case 4.
case 4,
Case
5,
5. Case 6. Case 7. Sorry. Case
okay,
7. Case 7, not 6.
case 7, yes,
And
then
case 8.
case 8, yeah. So this one, yeah, so we have these cases here. So this is the period prevalence, okay, between January and December. So that's how you find um, the period prevalence. Is that a hand? Good morning.
I'm asking for a clarification. If the case 2 has been counted twice, it was a point privilege for January, again you counted it.
Okay.
Actually, there are so many, even case 3, case 5, and case 8, they've been counted twice.
Okay. Yeah. So when you look at, let's go back to the issue we are looking at. So when we come to point prevalence uh, at in January, 1st January, point prevalence in January, we are looking at the cases that were there in January. Okay, the cases that were in January. So when you look at case 1, it is there, okay, in January. Then January we also have case 2 and case 3, case 7 I mean. Okay, so we are counting these one because they are there. Okay, then when you look at another where we counted case 1 is the point prevalence in December. So this person who got sick even before January, 1st January, was there as well in December. So remember, prevalence, we include the old cases and the new cases. Okay, so since it's still there in January, in December, we are still counting this person is still contributing to the prevalence at this time. Okay, because we are looking at the point prevalence. So when you look at the point prevalence in December, this person is still contributing because he's still there. He has not yet recovered or died, so it's still there, it's still being counted as a case. Okay, yeah, again when you look at yeah, this case 8, I think case 8 has also been counted. When we are looking at case 8, when you look at yeah, when you look at the 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 prevalence, okay, the point prevalence in December, this person is contributing, case 8. And when you look at the period prevalence between December and January, find that this person started um, developed the illness between this date, this period, and he is still there up to this time in December. So it's still being counted. So uh, prevalence looks at the old and the new cases. So as long as the person has not died, it's still contributing to the prevalence. Is it clear?
Yes, sir, it's clear. Thank you.
Great. Yeah, so now let's look at the relationship between incidence and prevalence. What is the relationship here? So prevalence depends on two factors. It depends on incidence, which are new cases, and the duration of illness. So this is where your question was coming from. Incidence and the duration of the illness. So assuming incidence and duration of illness are unchanged, so prevalence is going to be incidence times duration of illness. So for example, we have incidence, we have 10 cases, uh, of 10 cases per 1,000 population per year. That then mean duration of each disease, if it is 5 years. So that means prevalence is going to be uh, incidence times duration, which will be 10 times 5. It will give you 50 cases per 100,000 per thousand population, which is 5%. So as long as go back here, so this means that if um, if 10 people, okay, have this condition, okay, and it takes uh, 5 years, the mean duration of this disease is 5 years. So if we have 10 people, um, You have 10 people that become sick today. After 5 years, we are going to have how many people? We are going to have 50 people, because these 10 people will still be there, and there will be new cases that are coming every year. There will be new cases coming every year. So after 5 years, we are going to have 50 cases, because these 10 people will still be there. This is the question that you are asking. You see that the time that this person, the first person took, it took a long time for him to heal. So after 1 year, he was still there. But this person, the case 2, just stayed for a short time. We don't know if he recovered or he died, because we are not given that information. So after just a few months, this person was was no longer counted. Okay, so the duration and the incidence contribute, okay, contribute to the prevalence, or determine the prevalence of disease. Okay, so from that equation that we are given, the longer the duration, the greater its prevalence. So if the disease takes long, okay, if the duration is very long for a disease, we are going to have a greater prevalence or high prevalence. Just confirm with me, are you still able to see my slide?
It had disappeared, but now it has returned.
Oh, okay, okay, great. Yeah. So, for example, TB has high prevalence than incidence. Why? Because new cases keep cropping up throughout the year. Okay, then old cases persist for months. So find that for TB we have new cases that are coming up, but those who are sick, they are still there. They have not yet recovered. It persists for a long time. So you find that it has high prevalence than incidence. Okay. However, a disease will have relatively lower prevalence than incidence if it is of short duration, either due to recovery or death. Yeah. So if the disease, maybe the duration for recovery is short, or maybe people die fast, then we are going to have lower prevalence, because those cases will no longer be there. Okay. So when someone dies, is no longer counted in the prevalence, or is when someone recover, it's no longer counted in the prevalence. Okay. So that's decreasing in prevalence is caused by decrease in incidence and decrease in duration, which is can be recovery or death. Okay. So when we improve treatment, okay, we look at improved treatment versus change in prevalence. So if we improve treatment, what happened to the prevalence? So when we improve treatment, we are going to have decrease in duration of illness. When we have decrease in duration of illness, what happens to the prevalence? The prevalence is going to decrease as well, because those people who are going to recover will no longer um, will no longer count them as part of the prevalence. So people will be recovering fast and will be removed from the prevalence. So again, if we improve treatment, that means we can prevent death. But if there is no recovery, we can prevent death, but if there is no recovery, the prevalence will do what? Will increase. Okay? Anyone who understands the last point? I want someone to help us explain this last point. N1. Yes, Madam Nakazue. We are not able to get you. We are just hearing some sounds. We are not getting you.
Hello?
Hello. Oh, let me try to mute. Uh, Unfortunately, we can't hear you. Hello. Okay, seems like she has challenges. Anyone to try? Anyone else? Anyone? Okay. Madam Rachel, can you please help us? Okay, let's take for instance HIV and AIDS. Okay, before the ARVs, people used to die fast, right? Yeah, people used to die fast. So with the coming of ARVs, people now can live longer. Okay, the ARVs.
We can't get anything.
Oh,
Are you still teaching, sir?
okay, okay.
No, am I the only one who is not getting this, sir?
Oh, sorry,
I'm
Kansha
not
had muted
getting
my
it.
mic. Can you hear me now?
Yes.
Yeah, so I was saying that we couldn't hear the madam, so maybe someone can try. Someone else can try to explain this point, the last point. How do you understand it? Anyone who can help us? Mr. Edward. Yes, Madam Felistas.
I've just joined in. I've missed. I think I was cut by network.
Oh, yeah, I see. Yes, Madam Zodo.
Good morning, sir. Good morning, colleagues. Yeah, so if we improve treatment, prevent deaths, and no recovery, so this means that we've just improved the treatment and people will not die, but we'll still have new cases coming, and the old cases, they are not just dying, but they will remain. So, meaning there is no exit by death, there is no exit by recovery, and there is no prevention. So, meaning the prevalence will still increase because we'll still have these cases. They will not just die, but we'll still have them. And we have not prevented the new cases. So new cases will be coming and the old cases will remain. And so the prevalence will increase. Thank you, sir.
Exactly. Thank you very much. That's a very good explanation. So the good example that we can give is HIV and AIDS. Okay? Before the ARVs, people are dying fast, right? But with the coming of the ARVs, people are not dying, but they cannot recover. Okay? They still have the disease. So still have the old cases. And there are new cases that are coming in every day. That means the number of people who are sick is increasing. It will not be reducing because now death is prevented, which was reducing the number of cases. Okay, so thank you very much for that wonderful explanation. Okay, and try to. Okay, my slide is not moving, so I'm trying to move it. Okay, what's the use of prevalence? So the prevalence can be used to identify the high risk population, to identify those who are at high risk. Okay, we can also use it to estimate the magnitude of the health problem. We want to determine how big is this health problem. It can also be used for administrative and planning purposes. For those of you who be in management, you need to know the prevalence of each disease so that you can plan very well. You can know what medicine to stock. You can know how many hospital beds you need for those who need to be admitted. Yeah, you can know uh, the specialist that you need to have in the hospital. Okay, so that is it. The importance of this prevalence or this prevalence. So now let's look at this exam question which came. Okay, so I don't know if people can see this question clearly. Are you able to see? Okay, so this figure shows episode of an illness in a certain population. So figure one episode of an illness is given. We have 10 episodes of an illness in a population of 20. Yeah, so we have the total population is 20. Then we have 10 episodes of illness. Then there's this arrow which pointing down. It shows the dates of onset of illness. Then this plus sign it shows the date of death. Then the arrow which pointing up, it shows the date of recovery. Okay, then we have these cases. Now the first question is asking what is the incidence rate from October 1st, 1990 to September 3rd, 1991. Oh, is it? Yeah, 1991. They're asking what is the incidence rate. So how can we find the incidence rate? From October to September 1991. From here to here, how can we find the incidence rate? The total population is 20. So first, identify the cases that started between this, the new cases between this time. So let us identify them. Which case do we have? We have 1, 2, 3, 4, up to 10. So which cases started between October and September? Yes, madam.
So there is case 3,
We have case 3. Yes.
case 6,
Case 6.
7,
7
and 10.
and 10. Yeah, so how many cases do we have?
4.
So we have 4 out of what? Out of 20. Then we can multiply by 1000. This will give us what? What's the answer here? What will be the final answer, the incidence rate? Let's calculate 4 divided by 20.
200.
So it will give us, is it 200 per thousand? How are we dividing?
Yes, yes, that's what I. Sir,
Hello?
yes, I have a question.
Mm.
Why are we using 20 when 2 people died, like from January to what, to September, at 2 deaths?
Okay, yeah. So we have this one, this person died. Okay. Which one else died? Have
8.
this one who died. Uh, we have which one?
Case 4.
Case 4. This one also died. So which total should we use? We subtract this one.
No, I think we use the midpoint total
Yeah, the
as of
midpoint
1st April
as the 1st April.
population.
So what was the mid point population?
It was 18.
It was 18. Okay, so we remove these people that died before mid-April, right? So the
Yes.
mid population is going to be 18. Thank you very much for that observation. It's going to be 18. So let's find now the incidence rate. What should be the incidence?
It's going to be 222 per 1,000.
222 per thousand, right? Okay, my space is done
Yes.
this side. Yeah, so 222 per thousand. So that will be the incidence rate. Then now let's look at the what is the point prevalence on October. Uh, the point prevalence on 1st October 1991. Let's remove this one. point prevalence in October. Okay. So in October,
6.
this is October, right? Yeah. So we count these that were there in October. So we have 1, 2, 3, 4, 5, 6. Okay. And what was the total population at this time?
20 plus 20.
Yeah. So the total population here was 20. So it will be 60 over 20. So you can find the percent here. Prevalence with it can be in percentage. So what would be the prevalence? What should be the prevalence here?
30%.
30%.
Yes. Yes.
Yeah. So it's gonna be 30%. Then what is the point prevalence on April 1991? So 1st April 1991, let's identify the sick people at this point. Which one are the cases?
Yes, 7.
We have this one, have this one, 2, 3, 4, 5, 6, 7.
10.
Yeah, so these are the cases that we have. Now, what is the total population at this point?
It will be 20 since we're looking at the prevalence.
The total population. Remember, those who have died before this time, they are not counted as part of the population because they are no longer there. So we just want at the beginning of this time when we are counting, because these one will not count them. We are looking at the point prevalence. So we want at this time. So we remove this one. This one is going to be removed because this one is covered, so it's no longer part of the population in this one. So the second case and the case number 8 are going to be removed. Okay. So at this time, the point prevalence is going to be 7 out of 18. Okay. Is it clear on this one?
It's not clear, sir.
Okay. Ask question. Ask. Feel free to ask.
I was thinking maybe since we're looking at the prevalence,
Mm.
we counted these individuals from the start of the period.
Okay.
Why can't they be included in the why can't they be included in the population, midpoint population?
Okay. Yeah.
Points prevalence, yes.
Okay. So now let's take it to be more practical than just thinking on the paper here. So if we say right now, go to the clinic and count the number of people who are sick and calculate the prevalence. So when you go to the clinic, you are just going to count those who are sick. Okay? Or maybe I see where your concern is coming from. I was counting as these people, yeah, but yeah, it's okay because these people actually died. I thought maybe they recovered, but this plus sign shows that these people died. So if we take for instance today is is April, is 1st April 1991, then we tell you to go to the clinic or to a place, or maybe say go to Lusaka and give us the prevalence of HIV and AIDS in Lusaka today. Are you going to count those people who died between this period as part of the population, or you're just going to count people who are sick compared to the total population at that time? What are you going to do?
I think I'll count everyone. 20. And let's see
Including
if
those
I'm
who
taught
died?
to count the point prevalence from 1st April to 1st April to 30th, 30th September, meaning those two will not be counted. But if it's October to 1st April, I think I would count them.
Yes, so now we are looking at the point prevalence. Okay, so we are just counting those who are sick here. The point prevalence will only allow you to count only those who are sick at that time. Okay, so when you look at 1st April, so you're just counting these people who are sick. These people died before this time, so they won't be counted. They are not there. Okay, we don't even know them. We're not going to know them. They are not there. They died long time ago. So we just count these one who are here. Does it make sense to everyone? Okay, I've seen reactions, so I guess that makes sense. Yeah. So another question. Question D says we find what is the period prevalence on October. This is between October and April. What is the period prevalence between October and April? So let's count them. How are we going to count these ones? Hello? Okay. So we are when we are looking at the period prevalence, we are looking at the cases between the given time. Okay. So we're looking at the prevalence, the cases between October and April. So let's identify the cases between this time. So between October and April, we have this first case here. Let's count them. One. Are we together? I don't want to leave people behind, or you can find that you are out of the meeting. We have two, we have three, we have four, we have five, 6, 7, 8, and 9. Okay. What will be the total population? What will be the total population at this time?
To be 20.
To be 20. So it will be 1, 2, 3, 4, 5, 6, 7, 8. Is it 9? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it will be 9 cases this time around out of 20. Then you can complete to find the final prevalence. Then the period prevalence between October and September. What is the period prevalence between October and September? Anyone to try? I'll help you counting. Anyone to try?
So, sir, on the first one, the one just from counting, where have we included the two that died? Why are we using 9 instead of 7? Because the two died within that period. Why have we included them? Because you said in the previous explanation, you said we don't include those that have died along the way. We just count the ones that are sick at that particular time. I
Okay.
don't know. I need credit.
Okay. Yeah, so why are we counting this one? Anyone who can help us? I want someone to explain why we are counting these. Have this one who have died? That's a very good question. In this other one, these two people have died. But why are we counting them in the period prevalence between October and April? Why are we counting them? Madam Gladys, why are we counting these two people?
Let me try, sir.
Yes.
We look at the formula or the definition for prevalence. We say it's the number of cases which exist in a certain period of time. So
Mm-hmm.
now, if we say, let me say that we included those because those cases existed in this same period, regardless of the outcome, whether the persons died or not. Still, those cases they appeared, they existed in this same period. That is what I thought.
Yes. So we are including these people because they existed during this period. Remember the period we are looking. We are looking at this entire period from here. Okay, this entire period that is here. How many cases were there? You are counting all the cases. So if you look at it very carefully, we have even started counting those people that started before October. Because when we look at October, these guys were there. Okay, they are still there. So when you look at this period, like here, if you cut here, these guys were still there. So they still contribute between this period. We are looking at all the cases we had between this period. But when it comes to period prevalence, okay, no, sorry, to point prevalence, we just want to get at a certain time, okay, at a particular time, at once. we will not consider those who died. For example, the same example that I was giving, that if today you were to go to a certain place to count the number of people who are sick, okay, today you go there, you are going to count only those that you are going to find that are sick today. That is point prevalence. You are just getting at a particular time. Okay? For instance, we have the known prevalence of malaria, which is 35%, somewhere like that. But if we are to go to count today, you find that the prevalence is not 35. Okay? It's not 35 per thousand. You find a different prevalence because you're just counting today. So same applies here. When you are looking at the point prevalence, you just count those who are there. But when you are looking at the period prevalence, you want to look at the time interval from this period to this period. How many people were sick? So you count all the existing cases here. Is it clear?
Yes, sir.
Yes. Then let's look at the what is the period prevalence between October and September. Have we counted this one? No. So what is the prevalence between this time? So let's count this one. We have this one, the first one, the second, this one, this one, this one, this one as well, this one, this one, this one, this one. Yeah. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is now the point, or no, the period prevalence between October and September 1991. We had 10 cases between this time. But if you want to look at the prevalence between April and October, between April and September, that's where now you will not count these people who died before April. Okay? I think your question can come here. We will not count these people because they were not there between this time. But we are going to count one because he started from this period and he was still there between this period. If you look at this guy, was still there. Same applies to this one. It was still there. Applies to these others that started between this period. These people who started here, they are still counted as part of this because they were there during this period. Okay. Any question on this one? So if you can find more question on the prevalence, you can share in the group. Otherwise, this is the question that I had on prevalence from the past papers. Okay, so now let's look at the attack rate. The attack rate. So an attack rate is a variant of an incidence rate. Okay, so this one applies to a narrowly defined population observed for a limited time, such as during an outbreak. So when we are talking about the attack rate, we want to look at how many people become sick out of people who are at risk at a particular time. So normally this one is more like It's used when there's an outbreak. Okay, so for instance, there's an outbreak of a disease. Maybe we have 100 people. Okay, we have 100 people who become exposed. Okay, out of these 100 people, maybe 20 people become sick. Okay, so the attack rate is going to be 20 out of 100 people who are exposed. Okay, then the attack rate out of 100 people who are exposed, so the attack rate is actually multiplied by 100. We want to find more like a percent, okay, of how many people become sick. So it's going to be 20 out of 20 of out of 100 times 100. So it's going to give us what? 20%. So this one is going to become an attack rate. Okay. So in short, an attack rate, just like I've said, we want to know how many people become sick out of those people who are exposed, and it's normally used during the outbreak, okay, or during an epidemic. Are we together on this one?
Kindly repeat yourself, sir. I didn't get.
Okay, so we said an attack rate is the number of new cases among the population, who a population that is exposed to a risk factor. So for instance, you go to the wedding, 100 people go to the wedding, they eat food. Then after they eat that food, there is an outbreak of food poisoning. So an attack rate is how many people become sick out of people who eat that food. Okay? And it's expressed as a percent. So this is the example that I was given. If we have 100 people who go to the wedding and eat the food, after they eat food, 20 people uh, develop diarrhea, okay, due to food poisoning. So the attack rate is going to be calculated as the number of cases, number of new cases among these people who ate the food, okay, over the total, how many were they? So that is an attack rate. Then you multiply by 100. Okay, you multiply
All
by
right.
100. Yeah, so that is an attack rate.